Okay, we're starting a new unit, unit 13. It's all about complex numbers, starting on 13.1, imaginary numbers. Okay, so in equations such as x squared plus 1 equals 0, they have no real solution. So mathematicians define the imaginary numbers to represent their solution. Okay, the imaginary unit, or what we call I, is defined as the square root of -1. This is useful when working with square roots of negative numbers. Okay, a pure imaginary number is written in the form a plus bi, where a is the real part and bi is the imaginary part. Okay, so let's take a look at simplifying some negative square roots. Okay, so our step 1 is always rewrite the square root of -a as the square root of -1 times a. Then we break a down and we simplify the -1 as I under the radical there. Okay, so what does this look like? This looks like the square root of -9. Okay, well, I can say this is the same thing as the square root of -1 times the square root of 9. And then I know from the notes up above that the square root of -1, that's what I is. So I can also say this is I times square root of 9. And then the square root of 9 simplifies to just 3. So I've got I times 3. And how we would write this in standard form would be 3I. Okay, so your number and then the I goes after. Okay. Looking at that again, at example 2, I can simplify this, or I can break it down into the square root of -1 times the square root of 80. Okay, well that looks like I times the square root of 80. Square root of 80 simplifies to 4 square root 5. And then how I'd write this in standard form would be 4, then my I, and then my root 5. Okay. Okay, now I'm going to skip a step here in a way, because instead of writing that I can break this as a square root of -1 times the original, I can also just say that I know this is going to just end up being an I times the square root of 5. Okay, so that's a little shortcut. You don't have to break it down. If you know that anytime there's a negative, you can kind of just pull that negative out and replace it with an I. So here I pulled this out as an I. Okay, so I'll do that again on example 4. I'm going to pull my I out. Yep, this sounds kind of funny, but that's what we're doing. We're taking that negative, pulling our I out. Okay, and then we've got I square root of 32. And then the square root of 32 simplifies to 4 square root 2. So I have 4I square root 2. Okay, so not too bad. Most of this can be done in the calculator. We just have to remember to pull that I out, and then the calculator does it for us. Okay, when we move on to solving equations, though, there's just a couple extra steps here. Okay, so I'm solving for x on example 5. So I'm trying to get x all by itself. So I'm first going to subtract 81 to both sides. So I end up with x squared is equal to -81. Then, to get x all by itself, I have to square root both sides. So if I square root the x here, I'm going to end up with just x is equal to plus or minus the square root of -81. Okay. We got to remember that plus or minus, because we're still in a quadratic where we should end up with 2 solutions. And so right here, this is what guarantees we have 2 solutions. Okay, and now this looks like what we've been working on in the past couple examples. I'm going to pull my I out. Okay, so that's plus or minus I square root 81. And then the square root of 81 simplifies to just 9. So I can say we've got plus or minus 9i. And that would be my final answer. On number 6, I'm going to do the exact same thing. I'm trying to get x all by itself, so I'm going to subtract 15 to both sides. It's going to leave me with 4x squared is equal to negative 24. Then I'll divide both sides by 4. That'll give me x squared is equal to negative 6. And now I need to square root both sides. So I get x is equal to plus or minus the square root of negative 6. Then my last step here is I'm going to pull that I out. So I've got x is equal to plus or minus I square root 6, because the square root of 6 doesn't simplify anymore. So that's my final answer. Okay, example 7 and 8 we're actually going to skip. We're going to jump to the next page here. Okay. Next page talks about the powers of I. Okay. So this first line is going to sound a little redundant, but I to the power of 1 is just I, right? And I is just I. Yes, I equals I equals I. So I know, life-changing. But after this first step, it gets a little more interesting, okay? I to the power of 2 would be like I times I, right? And that would be like the square root of negative 1 times the square root of negative 1. And the square root of negative 1 times the square root of negative 1 is just negative 1. So I squared is equal to negative 1. Then I to the 3 would be like I squared times I. And that would be like negative 1 times I. So it would be like negative 1 times I. So I to the 3rd is negative I. Then we have I to the 4th, which would be like I squared times I squared, which would be like negative 1 times negative 1, which would be like 1. So as our power changes, our answer over here also changes here. Okay, but the good thing about this is once I jump over to I to the 5th, that would be like I to the 4th times I to the 1, right? I to the 4th is just 1 itself, so this is just like I. Same thing with I to the 6th. I could say this is like I to the 4th times I squared. And so that would be like 1 times I squared, and I squared is negative 1, so I to the 6th is also negative 1. Then I to the 7th would be like I to the 4th times I to the 3rd, which would be like 1 times I to the 3rd, which is negative I. And then last but not least, I to the 8th would be like I to the 4th times I to the 4th, which would be like 1 times 1, which is 1. So this pattern is going to keep repeating forever. And what we're trying to do here, essentially, is trying to condense it down to either any of these 4 right here. So if we look at example 9, 10, 11, and 12, the easiest way to simplify these is to look for a power or like a multiple of 4 that is less than our number. So what I mean by that is I've got I to the 15 in example 9. Okay, so I'm going to break I to the 15 into I to the 12 times I to the 3. The reason I'm breaking it into a multiple of 4 like this is because I know any multiple of 4 is just going to result in 1. So this would really be like 1 times I to the 3. And then I to the 3 I know is negative I. So it's like 1 times negative I, so it's just negative I. And that would be my answer there. Then for I to the 62, I'm looking for a multiple of 4 that's like close to 62, right under 62. So I'm going to break this one into I to the 60, because I know 60 is a multiple of 4. So that'd be I to the 60 times I to the 2. And then I know that I to the 60 is just going to go away because it's a multiple of 4. So I end up with just I to the 2, which I know is negative 1. Then on example 11, I'm looking for a multiple of 4. Well, I know 24 is a multiple of 4. So I've got I to the 24 times I to the 1. And then I to the 1 is just I itself. So that's my final answer there. Then similarly, I've got I to the 31. So a multiple of 4 would be like 28. So I to the 28. That leaves me with I to the 3. I to the 28 will go away. So I'm just left with I to the 3, which I know is negative I. So this is also negative I. And that's how we simplify the powers of I. But now, the reason why we do this is because when we're multiplying imaginary numbers together, we can end up with i's with high powers, but they should always simplify down smaller or into one of those 4 options. So if we're multiplying, then what we want to do is take our regular numbers, like our 4 and our 7 here, and we're just going to multiply those like we normally would. So 4 times 7 is 28. And then we're going to multiply our i's. So we have 28, and then I times I is I squared. But we know that I squared is the same thing as negative 1. So it's really like 28 times negative 1, which means our final answer is negative 28. Okay. Now in example 14, I've got negative 4 times 2 times negative 9. Negative 4 times 2 times negative 9 is 72. And then I times I times I is I to the 3rd. But then I know I to the 3rd is the same thing as negative I, which means I'll get negative 72I as my answer here. Okay, on example 15, I've got 2i to the 3rd over here. Okay, so this 3 is going to go to my 2 and to my I. So 2 to the 3rd is 8, and I to the 3rd is just I to the 3rd. And then I still have 5i over here. And now if I take 8 times 5, that's 40. And then I to the 3rd times I is I to the 4th. And I know I to the 4th is just like 1, so that means that my answer here is just 40 times 1, which is 40. Okay, on number 16, same thing. I'm going to distribute this 2 to my I and to my regular number here. Okay, so I am going to end up with an I squared times 3, the square root of 3 squared, or that's a cube, squared. So those are going to cancel each other out. Okay, so that's going to be like I squared times 3. And then on the right hand here, right hand side, I've got negative 8 squared, which is going to be like 64, and then I squared. So I'm going to rewrite this down here. That's going to be 64i. And I'm also going to erase this and rewrite it as 3i squared. Okay, so I didn't change anything, I just rearranged it to look more standard. And now I can multiply these how I have been. 3 times 64 is 192. And I squared times I squared is I to the 4th. And I to the 4th is just 1, so my final answer is 192. Okay. In example 17 and 18, it doesn't have i's already. I have to first take out the i's. Okay, so I'm going to rewrite this as I times the square root of 18 times I root 10. Okay, now I multiply my i's together. I get I squared. And the square root of 18 times the square root of 10 is the square root of 180. Then if I simplify the square root of 180, it's 6 square roots of 5. So it's 6i squared root 5. And then I squared is negative 1. So it's 6 times negative 1 root 5, or negative 6 root 5. Okay, and then our last example, 18. I'm going to pull my i's out first. That's the first step. So I've got I root 24 times I root 3 times I root 2. Now if I multiply all my i's together, I get I to the 3rd. And then the square root of 24, the square root of 24 times the square root of 3 times the square root of 2 is the square root of 144. Well, I to the 3rd can be written as negative I. And then the square root of 144 can be written as 12. So I've got negative 12i as my final answer there. Okay, so there is no Delta Math today. However, there is some questions on this back 2 pages here. I want all the odds to be done. And then once you're done with that, you can come and either myself or Mrs. Alderoyd will give you a stamp. And that goes for this page, all the odds, and on page 5, pages 4 and 5, all the odds. Okay, thanks for watching.